Read that you have to wait for n flips is equal to the minus n. Where did this come? That's a separate story. Where did it come from? Somebody tells this to us, and they ask, and those probabilities are plotted here as a function of n, and you're asked to find the probability that the output. It tells us that if we have the new probability of B is equal to 1. Okay, how do we revise?
Okay, so if we see like the probability of, say, for example, ABC given ABC, kind of want to just get like an intuitive and like intuition for kind of comparing like the left and the right here. So if they're kind of like fully equal, if they're like 1-to-1, then so given that the probability experiment ran and the outcome is one of these things. So basically, if it's one of these things, we're saying what's the probability that, so we're saying one of these things happened, and now what's the probability that just one of these things happen? So this is a 1. So this is kind of 1-to-1 here. So it's like one of these things happened. So what's the probability? So kind of want to look at it almost like this. So maybe let's look at kind of like maybe like the simplest cases. Let's say that there's only one outcome in our whole sample space, and not even our whole sample space or whatever. These are just two events. So we'll just say, what's the probability of A given A? Well, so one of these things happened. What's the probability that one of these things happened? Well, this is like 1-to-1. Given that one of these things happened. So we know that A occurred. So what's the probability that one of these things happen? Basically, what's the probability that A will occur? Well, it's 100%. So now maybe like what's the probability of, maybe, how about let's go like A, yeah, how about this? It's the probability that A, the event AB given A. Well, the overlap here is this. So one of these things happened. So we know that like A happened. So what's the probability that one of these things will happen? Well, what's the probability that either A happens or B happens? Okay, now we're getting into like the full sample space. So yeah, we should think of it in terms of like the whole sample space is equal to like A, for instance, because if we don't think in terms of yeah, let's just keep it simple where the whole sample space in this case is just A right here. So now let's say like the whole sample space is just AB. So now A happened. Now what's the probability that one of these things will happen? No. What's the probability that this event will happen? Yeah. Yeah, it just, as long as it just matches one of those things, then like that's all you need. So A occurred, the event A occurred. So we know the outcome A happened. So what's the probability that one of these things will happen? Well, it's kind of like 1 to 1. And then like, what if we have like the probability, what's the probability of A given the event AB, where again, the sample space is equal to AB like this. So one of these things happened. So in the case that A occurs, like we're good, it's kind of like 100%. So it would be 1, but it could be that B occurs and then we are not in the, then this event does not happen. So this is kind of like, got kind of like A and B here. And it could be that B happens and then you kind of didn't make it, sort of thing. So basically just want to get an intuition for like this kind of thing where it's almost like, all right, so we have the probability of A given A, you know, this is equal to 1 because there's kind of like A just completely covers A. It's like a 1 to 1 kind of thing. If we have like the probability of about like A unioned with just like a single new element, a new outcome given A. This should also be equal to 1 because what's the probability that this event will happen? One of these things happened. What's the probability? Well, yeah, I guess like this thing is a subset. This kind of translates to when the conditioning thing is like a subset. This is like A, and then this is kind of like A unioned with this outcome. So we know that like this thing occurred. So what's the probability that this thing will occur? It's kind of like in there, it's like 100%. But if we say, all right, what's the probability of A given A unioned with that outcome? Then it's kind of like, who knows, like all bets are off. We have like A unioned with the outcome, and then we have A in here. And so it could be that, you know, we got the outcome. So we're kind of here, but like we're not in the other thing. I kind of want to see it like almost like the probability of, just think of it as two kind of like bars. It's like the probability of A given, you know, the same kind of bar here, and that's equal to 1. But if we have the probability of A given, no, I guess we have this. It's like A and O, A, you know, so wherever we get in here, we're kind of like also in here. So like, that's kind of like good. It's also like 100%. But now if we say, what's the probability of A given, let's do it a little smaller, A given A and O, you know, we just know that we're in one of these things here. So if we kind of got in A, then we're good. But if we got in O, then that's going to wind up not in it. It's kind of like missing it. So we're kind of doing this like intersection overlap thing. This is the conditioning universe. So maybe if we bring it to this problem here, probability. So B and A. So B. So if you kind of think about it, A and B, how can we think about A and B? We can, so the probability of A given B. Probability of A given B is equal to, basically, you know, write it down as like the probability of A. Say we have this bar thing that's A. Given, you know, so now what is B? It is A, but it's kind of like more stuff too. It's kind of like A, but it's got this like, it's got this other stuff too. It's got this this B minus A stuff. So we've got kind of this same kind of overlap here. So again, if we kind of like are in here, we're good. But if we're over here, then we are not good.
Is the here B where you the is just calculation and simple. So inside the sample, so let's make this into a numerical example. So inside the sample space, this part of the sample space, let's say, has probability 3/6. This part has 2/6, and that part has 1/6. I guess that means that out here we have 0 probability. So these were our initial beliefs about the outcome of the experiment. Suppose now that someone comes and tells you that event B occurred. So they don't tell you the full outcome of the experiment, but they just tell you that the outcome is known to lie inside this set B. Well, then you should certainly change your beliefs in some way. And your new beliefs about what is like.
Kind of like, I don't know, I kind of want to think of it a little bit like probability of, I kind of want to draw it like this for some reason. Probability of A. Then we've got kind of like all this other kind of universe of stuff. given A and B minus A. So we kind of, so now the way we kind of look at it is like, we kind of like ignore all this, stuff. It's like not A, and we kind of like focus our attention like just on this like slice here. Should I do this as well? It's like this becomes our like new thing that we're just like, we're completely just focused on this little thing now. I guess you can kind of like draw this. And we're just like, we're basically just comparing these two things. You kind of like do the overlap of this and this. Kind of do this convolution thing almost, kind of like convolve this with this. So this kind of gets, when we do the convolution step, we kind of like, this kind of overlaps here. You kind of take this and kind of convolve it with this over here. And this part overlaps and you're good. And I think we kind of skipped over this, but maybe we kind of briefly mentioned this, but when you kind of say probability of A, this is always just equivalent to what's the probability of A given sigma. Like, you know that the outcome occurred in here. This is kind of weird to think about. It's like somehow doesn't seem to be like completely equivalent, because when I kind of think of conditional probability, it's almost like, I don't know, this is like cause and effect. If I just kind of look at like the probability of A, this is kind of just like a descriptive, thing, kind of like state of the world, just kind of like analyzing it, and like nothing's happened. But when you kind of write this down, we're almost implying that like, okay, something happened. The state of the world changed, and now what do we say about this? It's kind of like the difference between, you've got your kind of probabilistic like experiment box, your magic box, and there's kind of like a time and a place where like the experiment hasn't ran, and well, I guess, what does this mean then when in a world where that hasn't ran? You just say, what does this mean? This means, all right, when we run the experiment, the probability that A will happen is, whatever like the number is. But I guess you can even say this is like, you can kind of say this is both things. It's like, all right, before this runs, and let's say like, after it runs. Say before it runs, you say, all right, what's the likelihood that like the outcome is going to be an A? And now you say, all right, the thing has run. Now, what's the probability that it's A? It's almost like this is kind of mapping closer on to like this state of the world. Yeah, that's kind of interesting. But kind of back to this, I guess what would this mean when, you know, I mean, you can look at this like before this runs and say, all right, if this happened, okay, now this is kind of like conditional stuff. It's almost like, all right, if this happens, then, you know, what's the probability that like A is going to happen? It's not like this did happen. This is kind of like an if else kind of thing. Like if sigma, then A, you know, kind of thing. It's maybe like a better way to think about it. You can think of it in both cases, I guess. You can just kind of convolve outcomes and kind of overlap them and stuff. Yeah, this is like a different way to visualize this because like by default, there's no kind of like overlap. Like this is kind of just like a copy of the sample space. And in both cases, we kind of compare these two copies versus like this picture kind of shares the same sample space and like draws the events within the same sample space. This is a more compact maybe possibly representation. Yeah, sure. This is more compact representation. You don't need two copies of the sample space. But there's something nice about keeping these separate a little bit. So this is kind of like probability of, you know, let's just say like A is in sample space given, you know, this is just, you just give all of sigma. Oh, wait a minute. The probability of A given sigma, this isn't equal to 1. This is not equal to 1 at all. It's like it could be out here, and then A definitely doesn't happen. Dang. So I guess, yeah, screw this. I guess the actual thing that you should write is like, what's the probability of A? You can't say that this is equal to the probability of sigma given A. But if we just kind of want to like write down conditional probability in terms of some kind of event and something, you know, probability of sigma given A, this thing is going to be equal to 1 because it's like the probability of, you know, that it lands anywhere in the whole thing given, you know, A, it's just in here. So if it's in here, then it's definitely in here, 100%. So you're good. Okay. All right, that was cool. Get some more intuition on this. Seems good. I will see you guys later next time. Peace.